Early fishing lines were made of vines and braided horsehair. But today, fishermen rely on braided synthetics to reel in their catch. With a higher tensile strength than steel, these lines are unlikely to snap when they hook the big one. This fishing line may be thin, but that doesn't mean it's not strong. It's made of a synthetic called ultra-high molecular weight polyethylene. This same synthetic is used in milk jugs, water pipes, and even bulletproof vests. To make these fishing lines, numerous microfibers are braided into a single tight cord. An employee starts by threading fibers through needles. She pulls the needles through spring-loaded devices. The devices keep the fibers at an even tension as they unwind onto small bobbins. These bobbins are designed to fit in the braiding machines. The machines are called maypole braiders because the spools spin like dancers around a maypole. As they spin, they weave the strands into a tight braid. There are 4,500 braiding machines in operation at this factory. Producing a tight braid is slow work. It takes about 10 days to braid a 7,500-foot section of fishing line. Big spools overhead slowly revolve to take up the braided polyethylene line. At the same time, a worker fills a metal tank with hot water and adds yellow dye to it. A pump at the bottom of the tank keeps the water moving to evenly distribute the dye. He stirs it a bit while he inspects the mixing job. They heat and pressurize the dye in a tank filled with fishing line. The dye penetrates all of the strands for an even dye job. These fishing lines go through a different process. They unwind through metal eyelets into a tray of yellow silicone resin. This proprietary resin makes the line abrasion resistant. It will be less likely to break if dragged across a surface like a rock. Next, the line travels through an oven to cure the resin. It travels over a series of tensioning rollers as it exits. Then the line goes through an abrasive eyelet which removes external contaminants. Finally, it's rolled up by a spool. Now it's over to a test station. A technician clamps a piece of fishing line in a testing apparatus. It pulls the fishing line from both ends until it breaks. A gauge measures the line's breaking point. It snaps at 118 pounds of pressure, exceeding requirements. With the test piece of fishing line approved, an automated system now transfers the line to retail-sized spools. It loads about 450 feet of line onto each one. A worker applies a label with product details and packages it in a cardboard box. It takes about 17 days to braid, color, and process a single spool of synthetic fishing line. Strong but very thin, it can be cast and reeled in with ease. If the fish take the bait, they may not be able to get away.